Bob Alsop of Shop Saber CNC. Around here they call me Router Bob. We've got a very interesting video for you. Now we're going to be featuring the Shop Saber IS Series 4x8 machine, and then we're going to be talking about some new concepts and what the role of the operator is in a nested base manufacturing shop. Now before we get into it, let's talk about how that role has changed for the operator. Nested base manufacturing absolutely revolutionized panel processing in the United States. And when we first introduced that concept, we were very careful to define the role of the operator, or to limit the role of the operator, because early on, basically the idea was nested base manufacturing put control of the shop floor in the front office. And then basically the operator on the CNC machine became really a material handler. All right, that worked fine. But things happen sometimes in a shop that you really can't control, and parts get damaged. So maybe a part gets run over with a forklift, maybe it gets damaged to edge banding, something like that. So the reality is parts have to be remade. We call that process remaking. Well, what has to happen then? Well, then someone has to go back to the front office and find out who programmed it, load the job, output that part or parts that were damaged, go back out the machine and run it. So Mosaic Software has introduced a new concept called the Cnc Operator. And basically it puts the software out on the machine control. It does require Windows on the machine control to do this. But it enables the machine operator to go back and find that part, output that part, and remake it on the machine. And it does all this by not empowering the machine operator. Basically the software that's running on the machine control is the empowerment. So we've been able to accomplish that and still keep the role of the operator pretty much the same. Now, before we carry this further, let's walk out into the shop and let's look at the Shop Saber IS 408 machine. And then we'll come back and we'll go further into the software. This is one of my favorite Shop Saber CNC machines. This is the IS 408. IS means Industrial Series, 408 means it's a 4x8 table surface. Let me show you why I like this machine so much. You know, people ask me a lot, how do you evaluate the quality of a machine tool? And I said, well, I start at the material first. What kind of material is it made out of? The IS series are made out of structural steel. It's the same thing they make bridges out of. And we use that because the characteristics are very predictable. Therefore, we can use design software and evaluate the engineering because of that. So that's the first place you start at. And I look at how thick the walls of the tubes are. And that's where you start. Then the next part of that is how's the welding? Is the entire base frame one piece? We really want as few pieces as possible. So on this machine, this entire base frame is one weldment. And we'll look closer at that in a minute. The frame system really only composes of 4 parts: 2 support posts, a base frame, and a gantry. Now let's look at the gantry and the support posts a little bit closer. Okay, this is a support tube. There's one on each end. They're weldments. This is a gantry itself. It's a weldment. It's structural steel. It's reinforced. These frame components are why these machines cut so accurately and produce such good edge finishes. Now let's go down and look at the base frame a little bit closer and see what's under the hood. You know, what I like to do is look inside the machine. I like to see areas that I'm not supposed to see, because that tells me a whole lot about the builder. You know, is the quality inside also? First thing I look here, if you look at that structural steel tube, is how thick the walls are. That's a pretty good sign that they're using the material and they're designing it correctly. I look at the welds. A weld is a signature for the welder. And when you see good welds in there, you know the welder's really skilled. So you know you've got really quality work being done. Now this is quite interesting because you have 1, 2, 3, 4 vacuum ports. Now what happens is this frame member down here is actually part of the vacuum system. What you don't see is we have a 4-inch fitting that goes into the back that supplies vacuum to that. Then it's distributed with these large tubes out to the vacuum table. What that means is you get the maximum amount of vacuum out to the table to hold your parts. Now let's look at what is required to make the machine actually move. Machine motion is controlled by these contour guide rails. And if you notice the spacing on them, that's determined by the computer software we design the machine frames with. We use a process called finite element analysis, and it evaluates all the designs, and that's how we get this spacing correct. then the components that move back and forth move on these. So you'll have a set of guide rails on the x-axis, y-axis, and z-axis. Now let's look at what actually makes the machine move along these rails. The IS series CNC routers from Shop Saber have precision ball screws in all 3 axes. Now I get asked a lot, what's better, a ball screw or a rack and pinion? Well, it's real simple. I answered it with a question. I said, why don't they use rack and pinions on metalworking machines where they're really, really accurate? Well, the reason is they're not as accurate as the ball screw. That's the truth. Now, does it matter? Well, both systems make parts. On typical cabinet parts, you might not be able to tell the difference, but when you get into MDF doors and you get into plastics and you get into small letters, all of a sudden the backlash that's inherent in rack and pinion shows up. Ball screws don't have that play. That's why they use them in metalworking mills. Now, let's get further along on this and let's talk about what actually makes that ball screw system work. The actual motion in the machine is controlled, in this case, in the y-axis by rotating the ball nut. So as that rotates, it moves the machine back and forth along that precision ball screw. But the rotation is determined by this AC digital servo motor. In this case, it's Mitsubishi. And we have glass scales on there that have a resolution of 150 times more than a typical competitor. Now, the final part of machine motion is the control itself, so let's go take a look at that. We created the Shop Saber machine controller on a very robust control architecture, so they'd be rock solid and very dependable and reliable. All right, one of the things that we designed was a control interface that virtually anybody can learn to use. It has to be simple, so that you don't have to hire an engineer to run the machine. One of our other criteria was also to have a Windows environment available, because we might want to run other software. First, we want connectivity. We want to be able to send files out wirelessly to the machine control if necessary. We also wanted to be able to run software on the control itself in case we needed to. So that worked out really, really well. The control is rock solid. Now let's look at the actual spindle that's on this machine, because the spindle is going to do the cutting. The IS series CNC routers come with Hsd spindles. This particular machine has a tool changer, so this is an ATC spindle. Now we offer these spindles in a number of different horsepower ratings depending on what you need for your application. Now there's something I also want to point out on the design of this, and this comes out of finite element analysis, and that's these support brackets on both sides of the spindle. They actually attach to the spindle mounting plate and they make the whole structure much stiffer. The direct impact of that is you get better edge finishes and more accuracy. Now let's look at the vacuum table. That's the final part of the machine system. You know, one of the things I really like about the tables we put on the IS series is how we machine the vacuum access. Now first off, this is a phenolic table, and you notice there are 4 zones in here, and then we can actually use gasketing to control those. But here's something unique. You notice this machine is 4 feet wide. It's a 4x8, but there's actually an extra foot. So you can cut 5 foot wide material on this, which is really nice if you're cutting 5x5 Baltic birch. Now the machine also comes with part locator pins, and so I can use those to help locate the position. And then you notice I'm using the Shop Saber wireless control too, so that works out really nice. It makes all this machine setup really, really simple. Now let's go look at the actual vacuum pump that we're going to use tonight. We're using the Shop Saber F4 vacuum pump. Now it's a really, really unique high-tech system. First off, it runs on single-phase power, but it has a suction capability of roughly a 20 horsepower regenerative blower. Here's how we achieve that. Number one, we started with some really, really, really high-tech motors. But if you look at regenerative blowers, they have to have a relief valve on them so that they don't get hot. So the relief valve basically cuts the limit of how much vacuum they can produce. Well, in this system, we figured out a way to control the heat. So therefore, we can turn the boost way up on the pumps. So we get a lot more output from even these smaller pumps. And plus, there's 4 separate motors, so you can turn on the number you want. If it's a small job, you run one. There's actually valving in between them, so if you turn one off, it blocks it from the rest of the system. And you can see we're feeding into an actual 4-inch vacuum manifold, so it's an unbelievably neat system. Now that we looked at the IS408 machine, Let's go back up into the front office. Let's turn on the Mosaic software. Let's design a cabinet. In this case, we'll do a base cabinet that we do for a test. That's the first part of integration. When we set the machine up, so we cut a base cabinet, we put it together, and we make sure all the parts fit. Let's go to the office. Okay, now we're back in the front office. Let's open up Mosaic and let's look at a sample program. And I think what we'll do is we do a lot of cabinets here where we set up to test the machine setup. It's called integration. The integration means that you've configured the machine with the software so that when you output a cabinet part, everything fits. So let's start with that. So I've got a job I've set up already. Let's open that up. And it's one simple base cabinet. And here's what it looks like. If we actually look at it, this is a cabinet. This is our test cabinet. And remember, the idea of a test cabinet is to check the fits, make sure the joints fit. So typically, when you set up a CNC router to do a cabinet software, this is the first thing you do. You cut a base cabinet out and you put it together, and then you see if your joints fit and you make any adjustments. And then if that works, you do a tall cabinet and a wall cabinet. You put all those three together and you get everything fitting, the rest of the software works. So let's look at our construction method a little bit. This is a good CNC construction method to start with. It's blind dados. My back is the same thickness as the rest of the panel, so everything's made out of one part. That's a great place to start. So this would be our first test cabinet, is what we would call that. Okay? And remember, this is all being done in the front office, at the computer in the front office. Okay, so we'll close this. All right, so once our cabinet's set up, then we'll go to the optimizer. This is what's going to nest it, and we're going to tell it, we're going to make this out of 3/4 millimeter. And let's optimize it. Now, if everything worked out right, it takes one sheet. So if you can figure all the stuff right, you get your base cabinet cut out of one sheet. So now, that's what we're going to cut. That's going to be our base cabinet. Let's generate our G-code. And we'll create that. Save that. And this is what the G-code actually looks like. So in those few steps, we basically created a program. Now, this G-code program then gets sent out to the machine control, normally through the network. We'll go out to the machine control, we'll cut this cabinet out, and then we'll come back and we'll say, well, we've got a defective part, let's see how we remake a part. So let's go out to the machine control and let's go make this cabinet. We have our machine control network to the company network, so we've actually sent the program that we're going to run to cut that cabinet to the machine control, so the machine's waiting. We've also fly cut our spoil board, and we've also put our material on the table, and we use our part locator pins to line that up. There's one thing we haven't done. I've got one more tool that I need to use the tool touch off. This machine has a 10 tool changer, so we have automatic tool touch off, and it's a really great feature when you have that many tools to deal with. That's as easy as it gets. Now let's go make a cabinet. Boy, our cabinet nest really came out good. Isn't that a great way to build cabinets? Let's look at one of these parts. Wow. Boy, I love cutting melamine because it cuts so good. Now, if you look at the edge finishes on here, they're just impeccable. Perfectly straight. Boy, they're nice. And you can really tell on melamine if you have chipping. If you have a really well-designed machine tool, those corners are real sharp. In fact, you have to be careful handling it. Wow, that is neat. You know, that's what you get when you have a good machine tool. That's the kind of output you get. Now let's gather these parts and let's go over to the workbench and let's put our cabinet together and see what we got. Okay, this part looks good. The cabinet assemblers brought this over and they said it's a bad part. Well, it looks good here, but when I turn it over, I find a defect. The surface has a bunch of defects in it. Now, they're telling me that the material was that way. I think they screwed it up. It doesn't matter. Either way, I have to remake this part. All right, now, let's go over to the machine control, and I'll serve as the operator, and I'll show you the process for remaking this right at the machine control. So let's go over there and remake this part. Okay, here's how we're going to fix this. Now, on the machine control, I'm running the CNC Operator from Mosaic. Now, here's what that enables me to do. Okay, so what do we know? Well, we know we just ran a job, and we know we've got to replace the part because the material was defective. So what I'm going to actually do is open that job on here. All right, I find the sheet, and then we're going to remake it. So here's what we're going to do. I open up the job that has the defective part. I locate the sheet. I grab that part. I drag it to the remake bin. Then I create a piece of material that I'm going to make it out of. In this case, I'm going to use a remnant. I happen to have a piece that's about 30 by 40. That's big enough for that end panel. So I'll select that as the material. And then I simply drag the part from the remake bin over to the sheet, position it where I want it. Now I'm going to do one other thing because I'm not really going to put a full sheet on the table of material, so I want to make sure the part doesn't move. So I'm actually going to treat this part as a small part. Now what it's going to do is it's going to actually go around it twice. It's going to onion skin and then return. Then I hit generate G-code, hit the G-code, we'll save that. There's what the G-code looks like. I open that up on the machine control and I make the part. It's that simple. And let's see how it comes out. Well, our remake part came out really nice. That's a tremendous feature. And you know, what's nice about it is no one in the front office had to be bothered with making this. We empowered the machine operator to be able to replace that part just because of the software. Now, I'm going to take this part back to the cabinet assemblers. Okay, there is no defect on the back side, so they can't pull that on me. And let's see how the cabinet comes out. Well, our cabinet came back pretty good. The cabinet assemblers brought it over. It looks really good. They did a great job. You know, the craftsmanship's in the machine. You know, I really enjoyed doing this video because the 408 IS is my very favorite CNC machine, and it's so much fun to play with it. I hope you enjoyed the video. If you need more information, you can contact us at www.shopsaber.com. Thank you for watching.